Alrighty, folks. So, again, this is Mr. Whitmire coming at you pre-recorded yesterday, just trying to give you a little heads up as far as what we're going to be doing today in class. So I wanted to quickly review transformations with you one more time, then talk about inverses real quick, and then I'm going to cut you loose with an assignment. Okay, so once the video's over, please check the Google Classroom for your assignment. It's going to include both transformations and inverses all together there. Okay, so let's take a look at what we've got right here. That being said, transformations. All right, we've already kind of talked about this earlier, but I'm looking in I'm actually in your book right now on some of the practices that are in your book, or the notes that are in your book and stuff. So you can just follow along with this. Okay. What we're going to be looking at here today is taking this function right here, and we're going to be just transforming it and trying to figure out how to transform it. Okay. So, for example, here we know that if we want to shift things. If we want to shift things up or down, okay, that means we're going to take our function and add a number here to the outside. Okay, so we're going to take our normal function here that I have in black, and we'll call that f of x. We're going to either add or subtract a k to it to make it move up or down. Now, how much up or down? Well, that's going to depend here, right? So, for example, you can kind of like look at my original function here and where we want to move it to, and count by matching points. So for example, this point right here corresponds or matches to this point right here. And this point has to move up 1, 2, 3, 4. Right? Now let's say you picked a different point. Let's say you picked this point. This point would match to this point right here. And again, move it up 1, 2, 3, 4. Again, it's a distance of 4. So in other words, this red function here is 4 units up from the black one. How would we do that? Well, this function would be f of x plus 4 on the outside, right? Then if we want to move it down, like we do here with the purple one, well, how far down are we moving it? Again, match up corresponding parts. So like this point to this point, for example, we go down 1, 2, 3. So this one will be f of x minus 3, right? And that's how you do that, okay? So an easy way to transform this is to just shift all these kind of important points down 3 and then reconnect the dots, okay? All right, so that's the idea there, all right? Now, of course, we want to move things left or right. That means we're going to have it's that h inside there. We're going to shift things left or right. So x minus h or x plus h. Okay? You'll see here in the graph that the original function in black has been shifted to the right, to this red function right here. Again, match up corresponding parts. So, for example, here, this black dot goes to this red dot, right? And it goes to the right, 2. Right? 2, 2, 2. How do we go 2 to the right? F of x minus 2. Remember that when the number is inside with the x, it does the opposite of what you would expect. So, in other words, a minus 2, we would typically think, oh, it's going to go to the left 2. But no, since it's inside with the x, it does the opposite direction. It goes to the right 2. Okay? Here on the front, where we had f of x plus 4, the 4 was on the outside, so it does do what we would think it would do, up or down, you know, based on the positive or the negative there. So that's how we would do that, okay? Of course, if we wanted to shift things to the left, okay, and let me just go ahead and do that. I'll try and see if I can find a different color here. Let's see. Do I have, okay, I can maybe use my highlighter. Maybe that'll show up. I'll use this green one. That'll work, I think. Okay? Let's say I wanted to shift things to the left here. Let's say I wanted to shift it to the left 3. So I can just count here. 1, 2, 3. Put a point right there. Count from left here. 1, 2, 3. Count left here. 1, 2, 3. Count left here, 1, 2, 3. And I can just reconnect these dots then. Okay, like that. And now I have it shifted left 3. What would the function be? Well, again, if I'm going left 3, okay, this one would be f of x plus 3 to go left 3. Okay, and the red one, a little Christmassy here, is f of x minus 2 because we went right 2 from that black one. I know it's a little jumbled, but that's the idea, okay? So just keep in mind, if the number is in with the x, it's going to move left or right because that's what the x is in charge of, but it does the opposite of what you'd expect. A minus 2 moves right 2, a plus 3 moves left 3. If the number is on the outside, plus 4 or minus 3, right, on the outside there, it's going to affect the y values because f of x is like the y value, and it does it exactly how you would think. Up 4, down 3 there. Okay. Now, for stretches or compressions, remember that when we have the number here 2 in front, that means a vertical stretch of 2. All you're going to do then is take your points, like these, okay? Take their y coordinates, so the y coordinate is 2 right now, and just double it. Or sorry, it's negative 2. So what's double negative 2? It's negative 4. So it's going to stretch down here to negative 4. Same x value though. X value doesn't change. Here, y coordinate of 2, x coordinate of 1 stays the same, but y coordinate of 2 becomes double that, 4. Okay? And then here, x coordinate of 3, y coordinate of negative 2 becomes negative 4. X coordinate of 5, y coordinate of 2 becomes, well, 4 there. And you can just reconnect the dots here then, like so. Okay, you can see that vertical stretch. Okay? Over here, they actually did like a little table where they took the x values of the points, the original y values, and then you can see they just doubled those y values for the 2 times f of x transformation. So this red is, oops, I'll just do it this way, 2 f of x. Okay, the black is f of x. Okay, the same is true if we have like 1/2 in front instead. So like 1/2 f of x, okay, we would take our x value, negative 1, it's going to stay the same. The y value of 2 will halve that. Half of 2 is 1, so we're going to go to right here. Here, y value of 2, half of that is 1. Y value of negative 2, half of that's negative 1. Y value of 2, half of that is positive 1. So again, connect those dots, and you can see that kind of like squish that happens there. Okay, so again, in red, that is the 1/2 f of x function. Okay? So again, x coordinates stay the same for each point that you transform. Just the y coordinates, you do half or double kind of thing. Okay? Now, for this next one here, okay, we're going to do, let's see, f of 1/2 x, you'll see. So f of 1/2 x. Okay, so now in this case, we're going to take all of our x coordinates, okay? So let me see here. So here the x coordinate is negative 1, okay? And we're going to do the opposite. So rather than multiplying the x coordinate by negative 1, we're going to, rather than multiply by 1/2, we're going to divide that x coordinate by 1/2. So the x coordinate of negative 1 divided by 1/2, and you're going to do that on your calculator if you want, if that's weird to you. Negative 1 divided by 1/2, negative 2. Oh, you can't see it. Let me show you here with the light. There we go. Okay, negative 1 divided by 1/2 is negative 2. Okay, so this point, the y coordinate will stay the same, so it's not going to go up or down. We're just going to move it to negative 2 here. Okay, this one right here has a y coordinate of 1. Divide 1 by 1/2, and you get to 2. Okay, divide 3 by 1/2, and you get to 6. Divide 5 by 1/2, and you get all the way out here to 10. And so there's that stretch. Okay, like that. Okay, so when you have this here, this means divide x coordinate by 1/2. Okay? Because it's a horizontal stretch or shrink. Here for the vertical stretch, multiply y coordinate by 1/2, or here up here, multiply y coordinate by 2. But the x coordinate stays the same. Okay, so multiply here by 1/2, the y coordinate, multiply here by 2. Again, it's outside, so it does what you'd expect it to do. But in here, it's the opposite, right? So instead of 1/2 times x, don't multiply the x coordinate by 1/2, divide the x coordinate by 1/2, and that'll give you your new points there. Okay? And so one last thing here, we talk about reflections as well. All right? So when we, and I'm just going to worry about reflection over, well, all right, whatever, we'll just do this here. when we have negative f of x, okay, we're just going to reflect these over the y-axis here. So in other words, this point is 1 away from the y-axis, so we'll go 1 away in the opposite direction. This one's also 1 away, so we'll go 1 away in the opposite direction. This one is 3 away, so we'll go 1, 2, 3 away on this side. And this one is 1, 2, 3, 4, 5 away, so we'll go 1, 2, 3, 4, 5 away on this side. And reconnect the dots. Okay, you can see that reflection. Okay, and then here, this is f of negative x. That's reflecting over the x-axis. Okay, that's reflecting over the x-axis. And so this one will be, I believe it's reflecting over the x-axis, yes. Yes. Yes, reflecting over the x-axis will be like this then. So it's 2 away here, so 1, 2 up here. 2 away here, so 1, 2 down here. 2 away here, so up 2, down 2, so down 2 there. And again, reconnect the dots. And voila, there's your reflected. Okay? And again, that's f of negative x. Okay, reflect over y-axis. This is reflect over x-axis. Okay, this, remember, is even. Okay, this one's not odd. Okay, but when you reflect like that, it creates kind of like an even picture there almost. Okay, if you can do that to a single function. Okay, we won't worry about that right now though. Let's just worry about the reflection part for right now. Okay, so that's what I've got for you here, and then I'll give you guys an assignment with that as well. Now let's jump to inverses real quick. Okay. An inverse, all right, all it does is it kind of like undoes or cancels out a relation. So a relation and its inverse kind of undo each other or cancel each other out, okay? So when you have a function and you relate a number to another number, like -4 to -2 here, 0 to -3, 1 to 2, 4 to 1, all the inverse does is flip the coordinates. -2, -4, -3, 0, 2, 1, and 1, 4. It just flips those x and y values, okay, around. Okay? So again, if you have some coordinates to find the inverse, again, you take that -4, -2, flip them around to get the inverse. 0, -3 becomes -3, 0. 1, 2 becomes 2, 1. 4, 1 becomes 1, 4. That's all you got to do to find the inverse when you just have ordered pairs like that. Now, let's say we have an actual function, right? And we want to find the inverse of it. So for example, let's say we've got f of x equals 3x plus 4. How can we find the inverse of that? Well, you're going to follow these steps. Substitute y for f of x. Solve for x in terms of y. Or some people might say it this way. Let me do it this way. It might be a little bit easier just to see it. Okay, so take your function here if you're going to find the inverse, because that's what the directions say. Find the inverse function, f inverse of x, for the given function f of x. Okay, so let's just show that here real quick. Here's our function. We're going to change that f of x to a y. We're going to swap the x and y's. Just like that. Okay, now we're going to resolve this equation for y. So to get the y by itself here, we'll subtract 4 on both sides. You get x minus 4 equals 3 times y. Okay, and then we'll divide everything by 3. So we'll get y equals, because the 3's will cancel, x divided by 3 is going to be 1/3 x minus 4 over 3. And there's our inverse function. You could then further rewrite it one more time here if you wanted to do f inverse of x, 1/3 x minus 4/3, like that. Okay, that's how you can designate the inverse function there. Okay. So again, what do? We took our function, changed f of x to y, swap the x and y's, solve for y, you get to this, change y to f inverse of x like that. That's the inverse function. Okay, so this function, if you plug it into here, will simplify just down to x, or if you take this function and plug it into here, it will simplify down just to x. All right? And so that is our, that's how we find the inverse of those two equations. Okay? You'll see here, we can check that they're inverses by verifying that f inverse of f of x is equal to x, and f of f inverse of x is equal to x. In other words, you take the inverse function, plug it in for x into the original function, and simplify it. You should get just x. And if you take the original function and plug it in for x here and simplify it, you should get just x. And that does happen. You can kind of see they do it right here. Okay? Let's try this one. One more example here. We'll take f of x equals 2x minus 2. And again, change y for f of x. Swap the x and y. Okay? And then solve for y. So we'll add 2 to both sides. Divide everything by 2. We get y equals 1 over 2x and then plus 1. So the inverse of f is 1/2 x plus 1. Okay? And again, if I take this 2x minus 2 and I plug it in for x and then simplify, it should simplify down just to x, and it does. If I take this inverse here, 1/2 x plus 1, and I plug it in for the x here and simplify it down, it should simplify down just to x, and it does. Okay? One other property of functions and their inverses is that the function is the reflection, or the function reflected over the line y equals x gives you the inverse, like that. Okay? I think that should be good. I got to answer this phone call. I think that should be good. I'll give you guys an assignment on that just to get some practice with finding the inverses. Thank you. Rewatch this video if you need to. Hello? Yes. Nope, not a problem. It's planning anyway.